Welcome to my students. So today I am going to explain a very interesting concept about the mapping, and I am actually going to explain the mapping using the geometrical concept, right? So let's start today's lesson. Today's lesson is function, right? So I am telling you this concept using the geometry. So we all know that a function f maps, I am considering this function f maps ab to b. This is the function, right? So what is the definition of the function? Function is a rules of correspondence that assign every element to the set A to the unique element of the set B, right? So what is function? Function is a rules of correspondence that assign to every element. These two words are most important words. Every element to the set A to the unique element to the set B. So suppose I am telling you y square equals to x. Is it a function? This is not a function according to the definition of this. So why? Because it says it has y equals to plus minus, it is root x, right? So if I am drawing this, it just looks like this type. So for one input, it has two output. Suppose I am taking here 2. So it has output root 2 and minus root 2. So according to this definition, it is not a function because I am telling that the points should be unique. But this is not a unique. 2 and root 2. This 2 is assigned with 2 points. So that's why it is not a function, right? So I am telling you some example of function using this graph. So is it a function? Suppose 1 2 3 a b c d. It is not a function because this one assigned with these two elements. Now I am erasing this, right? Now it will be a function a b. So this b remain unassigned here, but well, that doesn't matter. So 1 to a, 2 to c, and 3 to d. It will be a function. But if there any element remain unassigned here, suppose this is unassigned here 4, then it will not be a function, right? So this is our basic concept of the function. Now what is the geometry of this? So now this f maps a to b is called function. If a line which is intersecting A and parallel to B, intersecting A and parallel to B, must intersecting to A and parallel to B, must intersect exactly one point of the graph, right? So must intersect exactly one point of the graph, then it is called the function. Otherwise it will not be a function. Now look at this, y equals to x square. Y equals to x square means this is like a parabola, right? Whose axis is x-axis, or here I am taking A and this is B. Now the line which is passing through A parallel to B. These are the line passing through A parallel to B, right? Okay, so passing through A parallel to B, this curve is y square equals to x. Now this line intersect 2 points. So here I am telling that exactly 1 point. So that's why it will not be function. So y square equals to x will not be a function, right? So if you have some idea about the graph tracing, or if you are given some known graph, then you will do it using this concept, geometry concept. Next, I am telling about the injective function. So what is injective function? Injective function means in mathematics, a function is called injective. If f of x equals to f of y, this implies x equals to y. Or contrapositively, you can say that for two distinct points x not equals to y, this implies, if this implies f of x not equals to f of y, then f is called injective or into function. Right? F is called injective or into function. The same thing. So now I will interpret it using the geometry. Geometrically, a function f maps a to b is called injective. Now the function f maps a to b is called into function. Injective or into, same thing. Into function if a line, so here I am taking the line which is passing, which is actually intersecting. So here the line intersecting parallel to B, and there was the point intersecting. So intersecting B and parallel to A. If the line intersecting B and parallel to A cut the graph of f at most one point, right? The most important word, at most, is the most important word, at most one point. Then it is called the injective function. So let's give you some example. Suppose I am taking the function x square equals to y, right? X square equals to y. So we all know that the function is like this. Suppose I am taking a and b. This is the function. So first of all, you will see that this x square equals to y. This will be the function with respect to this. Suppose this is x axis and this is y axis, right? This is our x axis and this axis is y axis. With respect to this notion, it will be a graph, because using the definition you can say that the line, this vertical line, meets exactly one point. So this will be x square equals to will be a function, and as well as this will be the injective function, right? This this will not be the injective. Why it will not be injective function? Because now let's draw it again. X, y. So this is the x square equals to y, means the graph like this. At most one point, the line intersecting B. So this is our B, right? And this is our A. The line intersecting B and parallel to it. So the line like this, and this line must intersect at most one, but it will intersect 2 points. So that's why this function, this is a function, because it fulfills the condition of the function, but it will not be the injective function. So this is not injective, right? So x square y is not injective. Now I am taking another function. Suppose y equals to x cube function. Is it injective? So look at the graph of this function. The function will be injective function actually. So let's draw the graph. This is the graph like this, right? So it's actually this type of graph. Now according to this definition, the line intersecting A and parallel to B, the line intersecting A and parallel to B, the line intersecting B parallel to A. So first of all I am checking that whether it is function or not. It is a function because the line intersecting A, the line intersecting in parallel to B. So the line like this, all line like this may intersect exactly one point. So it is a function. And now according to this definition, the line intersecting B and parallel to A cut the graph if at most 1. So this is our graph y equals to apex. Now the line, this line, right, which actually intersecting B, and this line are parallel to this line, A line. So these all lines cut this graph at most 1 point. So that's why this function will be injective function, right? This is a function and this is the injective function, right? So this is the idea of the injective function in geometric sense. So if you have if you are given some known curves, or you can track the curve, then it is very easy to identify the function whether it is injective or surjective. So now I am going to tell you about the surjective function. So for surjective function, the definition, this most just converted into at least, right? Then the function is called surjective function. So this function is called onto function. The function is called onto function if a line intersecting B parallel to A cuts the graph if at least 1 point, right? At least 1 point. So according to definition, this graph will be onto. This is injective or into. This is injective or into as well as onto, because this line cuts the graph at least 1. So at least 1 points. It may be more than 1 point, but at least 1. So that's why this is into as well as onto. So if a function is into as well as onto, then the function is called bijective function. So this function is bijective, right? Y equals to x cube is bijective function. Now I will tell you the example about this onto function. Now look at this graph. This is suppose A and this is B. So according to definition, at least 2 points, at least 1 point, not 2 point, at least 1 point, the graph should meet at least 1 point intersecting B and parallel to A, intersecting B and parallel to A. So these lines are all intersecting B and parallel to A line, right? Now I am drawing a graph. Suppose we have the graph like this. Suppose we have a graph intersecting B and parallel to A, right? Intersecting B, and suppose we have the graph like this. We have the graph like this. So here one thing you just notice that this is our graph. Now this line intersect the graph 3 points. This line intersect the graph 3 points. So here at least 1 point. It need actually at least 1 point. So that's why this I am taking here unknown function y equals to f of x. This is an unknown function like this. So this function will be onto function, right? This is onto function according to the definition, onto function, because it actually needs just at least 1 point, so it needs 3 points. Right, now it will not be injective. Why it will not injective? Because for injectivity it should be at most 1 point, but this is at least 3 point. Sorry, this is at least 1 point. For surjectivity it is at least 1 point, but for injectivity it is at most 1 point. So here just note that it is very simple to understand that this graph meets this line with 3 points. So at most 1 point, this condition actually violates. So that's why the function y equals to fx, it is not onto, it is not into function or injective. Right. So that's it, my today's discussion, and hope you all are enjoying my class. And this is the very interesting concept regarding the geometry, and I am trying to interpret this function using this concept, and I think this concept will be very helpful to crack any types of competitive exam regarding this higher maths.